In this video, let's find out the elasticity of a scale for a typical Cobb-Douglas production function. In previous video, we learned about the elasticity scale, and we told that elasticity of a scale measure the percentage change in output due to a 1% increase in all inputs. So now suppose we have a Cobb-Douglas production function y is equal to L to the power of alpha k to the power of beta. If we change the scale of our operation, it means we are going to scale all inputs by a kind of a scalar like t. Then this function will change to y of t. It means output after scaling. If output before scaling is some function of x, and x is vector of input, and these inputs are L and K, then output after scaling is some function of f of tx. It means a function of scalar, and also vector of inputs. Then it's equal to, in detail, f of TL tk. And in case of Cobb-Douglas production function, when we were talking about the return to scale, we find out that y of t, y or output after scaling, is equal to t to the power of alpha plus beta multiplied by L to the power of alpha k to the power of beta. If you don't know that, how we could find this one, I will put down the link for that video here, then you can watch that one, how the output after scaling in case of Cobb-Douglas production function will change to this kind of format. So then L to the power of alpha k to the power of beta is equal to the initial production function, which is y is equal to L to the power of alpha k to the power of beta. Then just simply, instead of L to the power of alpha k to the power of beta, we just write down y, or initial output level. Then y of t, just simply we write down here, y of t is equal to t to the power of alpha plus beta multiplied by y of t, or output after scale. So now, let's find out the elasticity of scale for this typical Cobb-Douglas production function. And we have the formula from previous video that we were talking about the elasticity of scale in general for introduction, also formula. The formula is that elasticity of scale for vector of inputs is equal to derivative of y of t, derivative of production function after scaling with respect to a scalar, which is t, derivative of output after scaling with respect to scale. This scalar, which is t, is a kind of like variable. It can take any values. Multiplied by t, or a scalar, divided by output after scaling. Then, instead of yt, you know that the detail is this one, f of t LTK. So either you can write down y of t or f of t LTK, or you can write down f of tx. Anything is okay, because they just explain the same thing. Again, instead of y of t, you can write down f of tx or f of t LTK. So now, we know the formula, we know the output after scaling, and we know the scalar t. So now it's easy to find out the elasticity of a scale for this typical Cobb-Douglas production function. So now, let's go and find it. Then elasticity of a scale for this Cobb-Douglas production function is equal to derivative of y of t with respect to t. We have y of t, this one, is equal to t to the power of alpha plus beta multiplied by y. Then the derivative for that one will be equal to alpha plus beta multiplied by t to the power of alpha plus beta minus 1 multiplied by y. Then this one multiplied by t over this y of t or f of t LTK. Then y of t or f of t LTK is equal to t to the power of alpha plus beta multiplied by y. Then simply write down here t to the power of alpha plus beta multiplied by y. Multiplied by y. Then this y will cancel out with this y. And we will have alpha plus beta multiplied by t to the power of alpha plus beta minus 1 multiplied by 1. Then move this t here. Then we will have t to the power of alpha plus beta minus 1. Again, then t to the power of alpha plus beta minus 1, t to the power of alpha plus beta minus 1, these two will cancel out. And finally, we will have that elasticity of scale, or Ex, is equal to alpha plus beta. In case of Cobb-Douglas production function, elasticity of scale is equal to the value of alpha plus beta. So now, let's talk about the final result. So if Ex, which is equal to alpha plus beta, is equal to 1, if the summation of alpha plus beta is equal to 1, then we will have constant return to scale. We will have constant return to scale. And if Ex, which is equal to alpha plus beta, is greater than 1, if we sum up alpha and beta, if it's greater than 1, the value, then we will have increasing return to scale. We will have increasing return to scale. And finally, if the results of Ex, which is equal to alpha plus beta, is less than 1, we know that if the elasticity of scale is less than 1, if you still don't know, I will put down the link here for the elasticity of scale introduction and formula. You will know that alpha plus beta if it's less than 1, they will have decreasing return to scale. So for a Cobb-Douglas production function, elasticity of scale depends on the value of alpha plus beta, this alpha and beta, the sum of alpha plus beta, the sum of alpha and beta. It means the sum of share of labor and capital in the production function. If this beta, so let's write down here, if you have this kind of format, alpha plus beta is equal to 1, it means beta is equal to 1 minus alpha, then our Cobb-Douglas production function will have this format, which is y is equal to L to the power of alpha, k to the power of 1 minus alpha. In this kind of Cobb-Douglas production function, for sure, we have constant return to scale. So if we have this kind of Cobb-Douglas production function, so for this typical Cobb-Douglas production function with this shape, with this format, we have constant return to scale. So overall, the return to scale, or the elasticity of scale for a Cobb-Douglas production function depends on the value of alpha plus beta. This is the solution for elasticity of scale for a typical Cobb-Douglas production function. Thank you guys for watching. See you in the next video. I hope you don't forget to subscribe my YouTube channel in order to grow more and more, to be happy together. Thank you so much. See you next time.